Back. Okay. Like I said, we're going to go through the Dyna-Coupler. Ours is the 2273, but this is the 2250 advanced cable locator, but it's basically the same, does the same functions. So I'm going to share my screen.
Okay, while he gets that screen in preparation, when you guys were out there at the field and on the underground part, where was our cable at in the ground? How was it installed?
In a conduit?
In conduit. So if I have a customer complaint of bad voltage and I've tested it and I need to repair it, what do I need to do?
Pull it out of the conduit?
Yeah, pull it out, pull a new piece back in, you're finished. This is more geared towards, and there's a lot of it still out there, that wire that's buried directly into the ground. So this is for cable that's not in conduit. Now, even if you have it in conduit, you still need to test it to see if it's bad. But once you have determined that, you just pulled out the old one and push in the new one and you're good to go.
Okay. Okay. And just a reminder, guys, this is for locating underground secondary cable, not primary, or locating faults. All right, we're going to play the video. At some points, we'll be stopping and starting to do a little explanation. And if you have any questions, just ask them at any point.
Updates to this program have been added, which includes information describing enhanced features that are available on newer model locators only.
Can you guys hear that okay?
It's a little bit hard. Unshare it.
Let me stop this.
I know it's going to be tough when he starts talking. So reshare it. And in the lower left-hand corner, share computer audio.
Got it.
It's up.
See. All right. Come on now. Escape that. Oh, here we go.
Much better.
This is the Dyna-Coupler 2250 advanced cable locator. It's rugged, water resistant, it's lightweight, well balanced, and it's easy to operate. The transmitter is used to apply a signal to the conductor you want to locate, and the receiver is used to trace the path of the signal. Now, in addition to detecting the transmitter signals, the receiver can also detect signals from energized power cables. When you're tracing a conductor, this bar graph and numeric indicator shows the signal strength, which is at a maximum when you're over the cable in peak mode. There's an audio response that gets louder as you get closer to the conductor. In addition, there's a directional or differential mode that points to the cable's location. In this mode, the unit makes a distinctive warbling tone as you move to the left or the right of the cable.
All right, guys, the piece that he was just talking about there, that's the receiver he was holding, what he's holding in his hand right there. And like he said, you have a transmitter, which is the box that's on the ground. And that puts a signal onto the cable, whether it's, and there's several different ways you can do that. And we'll go into that more in just a minute. But the transmitter puts a signal on and the receiver will pick up that signal by those modes.
The receiver lets you get an estimation of the conductor's depth and signal current at any time simply by pressing the depth key, even when you're tracing a power cable. And if you have a Dyna-Coupler 2205 or 2206 EMS marker locating accessory attached and set to the alert mode, you can locate a marker at the same time you're tracing the conductor path. Or, if you're using an active duct probe to locate the path of or find an obstruction in a non-metallic conduit, you can use the receiver to locate the probe and to determine its depth. The switches are used to turn the unit on and off and to check the batteries, to select the trace mode, to select the appropriate frequency, to select the tone mode, to adjust the speaker volume, to adjust the gain, and to measure the conductor depth or the current through the conductor. On the bottom of the receiver are two jacks. The smaller jack is for headphones. The larger jack is for accessories such as the Dyna-Coupler for cable identification and the tone probe for pair identification. A standard toning coil for aerial fault locating can also be used. The transmitter has storage space for cables, ground rod, and some accessories inside the case and in the external pouch. The switches are used to turn the unit off and to check the batteries, to turn the unit on in the ohms mode to check loop resistance and foreign voltage, and to put it in the tone mode, to turn the unit on in the trace mode, to select one of 4 possible tracing frequencies, or to select all 4 frequencies simultaneously, and to select normal or high power level. There's also a display and an output jack. When you're tracing a buried conductor, the transmitter sends a current through the conductor. The current causes an electromagnetic field or signal around the conductor. The receiver detects the field, allowing you to trace the path on the surface.
Can you pause it there?
Yeah.
There are 3 methods.
Can you go back to that part? Okay. So did anybody catch what he said as far as the transmitter? What does it do to the cable? What's it putting on the cable? What did he say?
Sends
Electromagnetic.
electricity.
Yeah, he said, and it's kind of probably in terminology. He said it puts current on the cable. Well, you can't do that. You can't put current. You
Yeah,
can't
that's
put
what I
current
was
on
thinking,
cable,
yeah.
right? You can't put current on cable unless you have a direct connection to it, and then you have to have voltage and a load attached to it. It does send a signal, though. Okay, it's going to send a frequency signal, and that signal is going to be emitted by the cable that's in the dirt. I don't want you guys to get confused by that. Okay, Professor V.
Remember this next slide coming up.
Yeah, we'll pause it.
There are 3 methods of applying transmitter signal to a conductor: the direct connect method, the Dyna-Coupler method, and the induction method.
Okay.
Okay, so that's going to be a test question. I can guarantee you.
Yep.
And we'll learn about each different method that there is out there. But they're pretty self-explanatory, except the Dyna-Coupler. You'll see that in a minute. Direct connect method means I'm going to directly connect the transmitter to the conductor. Dyna-Coupler, we'll see. What do you think the induction method is?
Measuring the magnetic field.
Well, this is 3 methods of applying transmitter signal to the conductor. All right, Professor V, you can just go reverse just a little bit on this video.
We're back to where we were at.
Yeah. Bang. Okay. There's no direct connection from the transmitter to that cable that's in the dirt. He's inducing a signal onto it from the transmitter box. So that's induction, no physical contact. Okay.
Copy that.
Roger that.
Allowing you to trace the path on the surface. There are 3 methods of applying transmitter signal to a conductor: the direct connect method, the Dyna-Coupler method, and the induction method. This pedestal is a good example of where you can use the direct connect method because you have access to the shield of the buried cable. First, plug the direct connect transmitter cable into the transmitter output jack. Next, attach the black clip to the ground rod and place it in the ground 90 degrees from the suspected cable path. Now, this is the suspected cable path, so the ground rod goes over here.
Pause there.
Now, connect the red clip to the cable shield.
Say
Okay.
pause it.
Go ahead, Professor V.
Okay.
If the shield is grounded at the contact point, you'll need to remove the ground.
Okay, you can pause it there.
Press and hold the off key. A solid
All right, so go back to that. I'm sorry, I'd get so far ahead. Go back to where he was right there. All right, there you go, guys. Now, there's just some he goes through this pretty quick. But what he does in this connection method, and remember, we are in locating right now. We're not in fault finding. We just want to locate the cable in the dirt. And I'll give you this hint. Like out there at our field, when we went from the dip pole to the first switch gear, what was our suspected cable path? Do you think it went straight out from the pole down the ditch and took a right or a left into the switch gear?
Shortest distance possible.
There you go. Yeah, the shortest distance from point A to point B. And that's your suspected cable path. Remember that through your entire careers. If you see a transformer and you're looking for the next, pedestal and want to try to find out what the path is, well, find it with your eyes, and it's going to be a straight line.
Mm-hmm.
Okay? That's one part of this, suspected cable path. You don't have to be exact. Two is in the locate mode, he went through this very fast. This method here works by triangulation. So where is the ground probe placed in relation to the pedestal he's working on?
90 degrees away.
90 degrees away from the suspected cable path. That's vitally important right here. If you put it anywhere else, you're not going to get an accurate locate. Okay, go ahead.
If the shield is grounded at the contact point, you'll need to remove the ground. To check the batteries, press and hold the off key. A solid tone means the batteries are good. A beeping tone means the batteries are low, and no tone means change the batteries. It's a good idea to check the batteries after you finish using the locator to ensure they'll be good the next time you use it. Successful location of a buried conductor using the direct connect method requires a complete circuit. The circuit goes from the transmitter through the conductor, back to the transmitter through a far end ground and the ground rod. To test the circuit, press the ohms key. You should hear a solid tone like this, indicating the circuit is good. A beeping tone means you have a marginal circuit. A no tone means the circuit has a high resistance or is open, and the transmitter may not be able to apply enough signal for tracing. If the circuit is good, press the trace key and select the 577 Hertz frequency.
You want to stop it there and go ahead and get that taken care of, V?
Yeah.
Okay. Like I said, well, is he working on a power pedestal here, or is he working on telephone?
He's working on telephone.
He's
Telephone.
working on telephone. Telephone and TV cable, because of the shielding that's around it and the insulation that they use different frequencies. I make this real simple on you guys, and it's part of the transmitter and receiver properties. Just use all. There's an all selection that you have in there. So if you select all on the transmitter and you select all on the receiver, it's going to be measuring all of those at the same time. You really have the benefit of the full package, and you don't have to know, well, I'm testing this kind of wire, well, I'm testing this kind of wire, or whatever. If you just use all, you're covered for everything.
Okay.
Go ahead.
Use this frequency with the direct connect method when the far end is bonded. If it's not bonded, use 33 kilohertz or 200 kilohertz. For longer tracing distances or deep cables, you can apply a higher output by pressing the output level key.
When using the direct connect method, the transmitter output current number is displayed. A display of the word low, or a number less than 50, indicates a weak tracing signal. A number higher than 70 represents a strong tracing signal.
The Dyna-Coupler is an optional accessory that's handy to have when you can't connect directly to the conductor. You can use it on metallic pipes, secondary power cables at the meter, or primary power cables at the transformer. But be sure to use your company's safety procedures. The Dyna-Coupler connects to the output jack with its own cable, and it's then clamped around the conductor you want to trace. Press the trace key and select the 200 kilohertz frequency.
All.
You should also
Yep, just keep going. I'll just keep saying all. Every time he says frequency, we're going to use all for electric.
Use all.
use high power with the Dyna-Coupler, so press the output level key to select high output power. When surface access to a buried conductor is not available, you can still apply a signal to the conductor using the induction method. The transmitter signal comes from an internal antenna and couples onto the buried conductor. This is a good example of when to use the induction method. It's obvious something is buried here because the pavement has been repaired. Since there's no easy access to apply the signal, I'll have to use the induction method. To apply a signal, put the transmitter on the ground over the buried conductor and line up the lid hinge with the conductor path. Now, this is the suspected path, so I'll just line up the hinge like this.
You know when to pause it, V. Go ahead and go back.
Turn.
Okay, guys, so two important things right here. If the hinges are not lined up with a suspected cable path, you're going to get very limited signal out of it. The antenna orientation inside the transmitter goes down the handles. All right, that's one thing. Two is and I'll just ask this, does anybody see anything wrong with this?
Wrong with what specifically?
What he's doing? What he's doing? What is it, Nigel?
Oh, I mean, I don't see it. I was just agreeing. I mean, is it concrete? I don't know.
It'll transmit through asphalt, concrete, grass, whatever. Okay, I'll just give you guys a hint. Don't put a $5,000 piece of equipment in the middle of the road.
In the road.
Okay.
Oh, so he is in the middle.
I was thinking that, but I was like, I don't know if it's like a driveway or.
Yeah. All right.
Yeah.
Yeah. It'd be just as easy if you went off to the upper right-hand side there where it goes into the grass and put it on the edge of the yard.
Yeah.
All right.
Gotcha.
Yeah. Okay.
Just line up the hinge like this. Press the trace key to turn the unit on and select the 200 kilohertz frequency.
All.
You can also use high power, so press the output level key to select high output power when the received signal is weak. You should be aware, though, that the induction method applies a signal to every conductor in the immediate area near the transmitter.
Okay, that's important. Everything that's in the dirt is going to get a signal on it.
Yeah.
When you use the induction method. Water lines, sewer lines, anything metallic, it's going to have a signal on it.
So how do you know if you've located the right?
You don't. You don't. What you're going to have to do out there is, now typically companies do nowadays what they call a joint trench. So everybody's in the same trench. When you dig in your power, then telephone and TV cable follow along with you. I mean, that's the newer style of doing it right now. You have to do what they call potholing. I guess you know what potholing is?
Maybe where you dig a small hole to see what it actually is.
Exactly. Dig down a small hole and verify what you're locating.
Seeing the cable path with the receiver is a simple process. Turn the unit on by pressing and holding the on-off key. Notice the battery level mark on the left side of the bar graph. If the bar graph is to the left of this mark, you'll need to replace the batteries. First, select one of the 4 trace modes. Here, I will use peak. Next, set the receiver's frequency to match the transmitter's output frequency.
All.
If you're tracing a power cable without using the transmitter, select the power frequency.
60 hertz.
Before you begin tracing, you need to set the receiver's gain or sensitivity. Find a point of maximum response over the suspected cable path. Hold the receiver at a comfortable tracing height with the receiver's handle in line with the cable path and press the gain adjust key. The receiver automatically adjusts itself for a satisfactory signal level. You can tell when to readjust the gain by watching the bar graph. If it separates nearly all the way or closes completely, find a point of maximum response and readjust the gain by pressing the gain key.
The bar graph provides a visual indication of the relative signal strength being received by the locator from the cable being traced. Pressing the gain adjust key once sets the bar graph to the midpoint reference setting based on the strength of the signal being received by the locator at the moment the gain adjust key is pressed. Remember, you only need to press the gain adjust key once each time you wish to reset the bar graph level to the midpoint reference setting.
At any time while tracing, you can get an estimate of the cable's depth. Set the receiver on the ground directly above the cable, with the receiver's handle in line with the cable path. When you press the depth key, the numeric display shows the estimated depth and the relative signal current in the cable. The circled eye is also displayed. The current mode is useful for verifying that you're tracing the correct cable. Here, the transmitter signal was applied to the deeper cable. The other cable is carrying a weaker signal because of common grounding. This looks like two trace paths, so which is the correct one? Since the cable with the highest current is most likely the target cable, you have to check each response in the current mode. As you can see, the deeper cable has the highest current and is the target cable.
Okay, can you pause it there,
To reduce
Professor
the
B?
possibility that the trace signal will...
All right, so, Ryan, you just asked a little while ago, well, how do I know I'm on the right cable? In the induction method, you don't. Okay, he's still in direct connect down here on this locate. So now he's able to determine by different signal strength which one is the correct cable because he's direct connecting. Okay.
Gotcha.
All right. The other part is, he keeps saying current. I'd wish he'd say signal strength, not signal current in those situations, for one. And there was one other aspect. Well, you know what I'll do? I'll do a share screen later on. When he said measurement of depth, did he say he said it real quick, estimated. Okay. It's definitely an estimate. So don't go locating cable, and when it says 2 feet 1 inch, expect the cable to be exactly at 2 feet 1 inch. It might be at 1.5 feet. It might be 2.5 feet. It's an estimate, and especially if you're locating for somebody else, I didn't even give depths. Depths are not required. All right. So out there in the world, be advised, depth is not that accurate. There is a practice that he is using too that I don't agree on, but I'll talk about it later. Go ahead.
Deeper cable has the highest current and is the target cable. To reduce the possibility that the trace signal will get onto other cables, use the direct connect method at 577 Hertz with good far end ground.
In newer models, the flashing Hertz symbol indicates alternate frequencies are available. To change to an alternate frequency, press and hold the gain key while pressing the frequency key.
When a non-metallic pipe becomes obstructed, a 3M active duct probe is a convenient device that's used to locate the problem. The probe emits a signal that the receiver can detect, allowing you to locate it. To locate an active duct probe, turn the receiver on, select the ADP frequency, which in this case is 33 kilohertz, then select the peak trace mode. You have to hold the receiver so that its handle is perpendicular to the duct path. So I'll hold it like this, since the path is in this direction. If the bar graph stays fully closed or fully open as you're tracing the path, press the gain key. To make sure you're directly over the probe, turn the receiver until you get the strongest signal. And then move it across the path until you get the strongest signal again. To measure the probe's depth, set the receiver antenna on the ground directly over the probe and press the depth key twice for ADP depth.
Say pause it.
Yes, well, yeah, you can pause it now, and that's an estimate again. Guys, I never used a duct probe.
Me neither.
The problems that you're going to have with a duct probe is, one, they're very difficult to get down the pipe to the obstruction in the pipe. And two is you've got stuff on your truck where you don't need a duct probe.
Right.
So if there's an obstruction in the pipe, what's in the pipe?
The line.
The line is in the pipe. So you can actually go down to the point where it's either broken at with a fault finder, or if there's nothing in the pipe, take a piece of wire off your truck, push it down the pipe until it stops, then locate it out until the signal stops. That's a bad part in your pipe. Yeah. 37 years, never used a duct probe.
Mm-mm.
Good.
And press the depth key twice for ADP depth. This completes the presentation on the Dyna-Tel 2250 Advanced Cable Locator.
Mr. Shoemaker, I got to take this.
Okay, go ahead. Let me unshare your screen, please.
Hello? Yes.
Okay, I'm gonna do a share screen, guys, and mute. There, you got muted. A couple of actions that he's getting on here, and I want you guys to be knowledgeable of this equipment, and two is really good at it. So hold on one second. Okay, you guys should see a whiteboard up there, correct?
Yes, sir.
Okay. So a couple of things going on with this general practices right here. And me, I like precision. One is especially when you're starting to dig up somebody's yard. You want to make the smallest hole and do the less destruction as possible right here. I'll try to draw this in a diagram for you. Control. Here's my little stick man right here. This is me. Okay, and my feet. And I've got the wand in my hand like this, and I'm checking down into the earth what I want to check. I mean, it's good to find a general location. I'm just going to do it over here to the side here. If you want to arc the wand back and forth, such as this, that's good to just find the general spot of the cable that's in the dirt. Okay. Once you start finding the conductor, whatever you're trying to find in the dirt right here at the bottom, get a little bit more precise. And that can't be done with arcing the wand because you're locating way out in these areas when you arc the wand. Does that make common sense?
Yeah.
Okay. Once you start getting, and you find the initial cable right here, take that wand and use your feet, okay? And keep that wand head to where it's facing down, just like this. And you'll definitely get more of a precision locate on the conductor, okay? It's just keeping, instead of going back and forth with your hand, it's keeping it straight and move your feet back and forth and keep your arms straight, okay? That'll definitely help you in the locating process. The other part is, let me get rid of all this. And I've seen a lot of people do this, especially on the depth. Like I said, depth's an estimate. If you want to use it for an estimate, fine. Don't tell another company, yeah, our conductor's at 3 feet, okay? Because they're going to take you.
Would that make you liable?
It will. Definitely will. Well, Santee Cooper guy came out and he said that conductor was at 3 feet and we hit it at 2. All right, so that's on you, okay? So another thing that's going to help in this precision locating, when you've got the wand in a certain zone and you're facing it straight down, is in the depth process. All right, and here's my ground level right here. So here's what some people do. Here's my wand, they'll press the depth key from where they're standing. Well, this is 3 feet deep and this is 1 foot off the ground. What kind of measurement are you going to get on the wand?
4 feet.
4 feet, when it's really 3 feet in the ground. Make sure you put the wand on the ground. Another part of this is, especially when you start to do the doing the gain and getting the gain adjust and getting directly over the cable, and this is why I don't like to sway it back and forth like this is if I got, I'll start another one right here. I got the wand on the ground and I take my depth measurement, but my conductor's over here. All right, it's 3 feet straight down. Is it 3 feet when I've got it off to the side?
No.
No. Okay, that's not the closest point distance between 2 points. So you're going to give a false measurement here. Okay, that's going to be a false measurement, and that happens a lot when you sway the wand back and forth, trying to find maximum signal. Okay, is it going to take a little bit more time to do this? Yeah, not much. Okay, but especially when you're doing a depth measurement for yourself, get more precise and take your time and make sure you're directly over the cable that you're trying to get the depth measurement to. Okay, Professor V, are you back?
I am.
Okay, I'll get out of this and let you have share back.
Okay, I've got one more video.
Okay. Share stopped.
All right, guys, anybody got any questions about locating with the Dyna-Tel, just locating cable? Okay, I'm gonna share my screen again. Now we're gonna look at a little video of fault locating with the wand. Y'all see that?
It just came up. Okay, pause it real quick. Let me ask a question here real quick. All right, so does everybody know the difference between the two? Same piece of equipment. He's probably got a different model number. What's the difference between cable locating and fault locating? Does anybody know what the difference is between the two?
Yeah, I mean, cable locating is just finding the cable.
Right, finding the span in the ground, right?
Yes, sir.
Okay, what's fault locating?
Fault locating is
Yeah.
find a discrepancy in the cable as far
Excellent, excellent, perfect. Now, it's finding the bad spot in the cable. Might have been a dig in or a nick in the cable years ago. It might have, who knows? Guy could have put a shovel in it and not even known it, and then it started corroding and going bad. So those are the differences in the two.
Okay. All right, guys. Fault locating.
In order to pinpoint a fault, it is necessary to isolate the faulted section of cable at both ends. Connect the red lead of the transmitter to the faulted conductor and the black lead to the ground rod that you have placed in line with the suspected cable path.
Okay. Anybody tell me what's different with, locating a fault versus just locating cable?
This one doesn't use triangulation. This one goes down the line to see if it finds a break in the line.
Okay.
Yeah, I don't know if he's going to get it further in the video. It's in line and behind.
Right.
Okay, in line and behind. Don't put it over the path of the fault that you're looking for. Put it behind the path of the fault that you're looking for. Okay.
So it can trace down.
So it can trace straight down. It needs, yeah. Well, I won't get into the details of it. I don't need triangulation anymore. Okay. This is actually going to start going into current flow because I'm going to introduce voltage into the cable and current, and it's going to flow back to the rod. We want to keep that in a straight line, the ground rod in a straight line.
Okay.
Check the battery level of your transmitter by holding down the off key. Measure the severity of the fault by pressing the second key or the ohms key. Place the transmitter in fault mode by pressing the second key again. A flag will appear on the display under the fault icon, indicating that you are in fault mode. Step slightly in front of the ground rod, 1 A-frame distance, and push the A-frame into the soil to take a reference reading of the fault signal at the ground rod.
Pause.
Press the
Okay, go back to where he was standing on the ground. So he is actually standing behind the pedestal, and beyond the pedestal is the span where he thinks is bad. So he's taking a reference measurement right here, just in front of the ground rod, and it's going to give him a reference number or reference signal up in the display of his Dyna-Coupler right there. This is, if you want to give a good term for it, is calibrating. You're getting your first calibration right here of signal strength. Go ahead.
at the ground rod. Press the yellow reference key to save this reading.
Nice.
The arrow on the receiver screen will indicate which leg of the A-frame is closer to the fault. Continue fault locating, reinserting the A-frame probes while watching the receiver bar graphs. The bar graph on the receiver will fill toward the green band on the right side of the screen, indicating that the fault is ahead of you in the direction of the green banded leg of the A-frame.
Okay, pause it.
The bar graph fills toward...
You notice she's taking off some pretty big chunks, right?
Yeah.
Yeah, go ahead. I mean, if you got a lengthy span of cable out there, go ahead and walk it off a while. And then you'll start narrowing it down once you get a difference in direction. Now you'll notice, and this, a lot of people get kind of confused by this. You'll notice by the display, I've got on the left-hand side, a red and white banded bar. And then on the other side, I've got a green solid. Okay. It doesn't really matter. You just got to follow by looking at the one that's in the dirt. If I've got my red band in front of me, it's going to turn green on this one. If I got my green band in front of me, it's going to turn red. It just doesn't matter. Look at the display, follow the bands that you have as where the thing is sitting in the dirt. Just follow it.
Yep.
Green and red does not matter as long as you match what's in the ground compared to what's on the display.
the red band on the left side of the screen, the fault has been passed and is now behind you. Move back, inserting the A-frame every few inches until the arrows alternate back to green. Mark the point beneath the center of the frame. Turn the A-frame 90 degrees and insert it into the ground over the previously marked point.
Why?
Move the A-frame.
Because it's changing, trying to find the change in direction.
Yeah, remember, we're working on a suspected cable path. Okay, she might be 3 feet to the left of it or 3 feet to the right of it. She's got it longitudinally. Is that right?
Yeah.
She's got it laterally. Now she needs to find it longitudinally. Go ahead.
So when you say the red and the green to match, I see the red and the green on the bar now.
Right.
Okay, I think I answered my own question.
Just leave it right there, Professor V. So it should be, if the fault was in front of her, the handheld device is going to tell her to go green. All right? Make sense?
Yeah.
Okay. If she flips the wand around right now, doesn't even move, it's going to swap to red and white. But it's still in front of her. Get what I'm saying?
Yeah.
Okay. Good deal.
To the left and right, following the directions of the green and red indicators on the receiver. When the arrows reverse, turn the A-frame 90 degrees again. Pinpoint the fault by moving the A-frame in the direction of the green and red arrows. The fault is located beneath the center of the frame when the arrows change from one side to the other this final time. To verify the fault location, insert the frame's red probe directly on the spot identified. Pivot the A-frame in a circle around the red leg, reinserting the green leg in the ground every few degrees of the circle. The arrow should always point toward the red band on the left of the screen, indicating that the fault is directly below the red leg. After a fault is found and pinpointed, move the A-frame about 1 frame width away from the fault and insert it in the ground with the green banded leg towards the fault. Compare the signal level on the receiver screen with the fault level reference indicated in the lower left box labeled reference. If the reading is within 12 dB of the reference, the operator has found the major fault.
So pause it there. Go back to that point where he was showing the 67 and 60 dB. It's not uncommon, guys, especially an older conductor right here. That reference is vitally important to have. Once you get this conductor, you dig this up and you get this conductor repaired, what are you going to do with the Dyna-Tel?
Turn it towards the fault.
You know what we did, and we kind of got our hands slapped for it a couple times because we didn't do it, is we'd go down, we'd use this piece of equipment, we dig it up, we splice it out, go check the voltage and leave. Well, guess what? That's not the only fault that was in the conductor. Retest it.
Right.
Retest it. That's why we're using reference numbers here. Once you retest it, you've already got all the equipment out, and it's still showing a bad spot in your cable, you're going to get a new reference signal. Then you're going to do the same thing all over again. It's not common, but it does happen.
Okay.
I'm good, V.
All right. Well, that's the video right there, guys. I mean, anybody got any questions about fault locating with the 3M?
I mean, the vital things to remember, they're locating. That ground probe's got to go 90 degrees from the suspected path.
Right.
Fault finding, inline, and behind. If you get those things wrong, you'll be spending hours and digging tons of holes.
Yeah.
Trying to find out where the bad conductor is.
Does it matter if we lead with the red side or the green side of the wand, the horseshoe?
No.
No.
Right.
What frequency do we use?
All.
What frequency do we use when we're not using the transmitter?
60.
60 hertz, 60 hertz, right. You can use it by wand only. When we're using 60 hertz, do we need to have load or current flow on the conductor?
Yeah.
Yep, got to have that magnetic field.
Let's see what else. 60 hertz. When we're locating cable just with the receiver, where does the ground probe go?
In line
No,
and in line and behind.
no, that's fault locating.
90 degrees.
Oh,
90 degrees.
Well, just locating the cable itself with the receiver.
I thought you said fault.
90 degrees.
90 degrees. Okay. And what is the what piece of equipment? What's the name of this piece of equipment?
Dyna-Tel.
Dyna-Tel. So remember those things, guys. Okay. What are the three types of the methods used to locate the cable?
Direct connect method, Dyna-Coupler method, and induction method.
Correct.
Very good. Very good. Okay. Okay. All right, guys. It's 10:30. That wraps up the Dyna-Tel. Anybody got any questions about any comments? No.
How often will we actually use that, or would that be the locator company that would be doing that?
Well, fault locating, if you're on an underground crew, you might use it every single day, depending on where you're at. I know, like up in the Raleigh area with Duke, guys, they have nothing but some crews that are just underground, and that's what they do all day long, go out and locate bad underground cable.
Gotcha.
So
All day long.
all day long. They repair underground. Or if you're on a crew in King Street, like I came off of, we used it maybe once a month. So it really depends on where you go to your area, how much underground you got. But I carried one of these on my truck. And when I needed it, bam, it was there. I could, had it at my disposal to use. Didn't locate from, like if we got a locate call from somebody, we generally did not go out. The 811 service would call out the locator with, what's the USIC or something like that.
Mm-hmm.
And they would go out and do all the locating for us.
Your locating service that's locating for you, that could be multiple companies, and it can actually be the organization. So I've called in to locate, Verizon might come out and locate it, or a contract. I just don't know. Sometimes, a good many times, especially if it's a tight area with a bunch of stuff in the ground, and I need to dig in a service or put a pole in the ground, I'll relocate it myself.
Yeah.
I'll throw a locator on it just to make sure it's precise. Or if I see a telephone pedestal over there and no orange marks on the ground near to where I'm going, yeah, I'm going to break one out, okay, and locate it. One last thing before we take our break here, it's something I've forgotten. I'm going to draw some poles right here. Here's my overhead line. And I'm going to draw a transformer down here, pad mount transformer, and draw some secondaries off to the side here. Another pad mount, secondaries over here, whatnot. Guys, the locator, the wand itself, cannot discriminate in direction. So if
So you can pick up the overhead?
You got it. It will pick up overhead, primary, and secondary. So if you're walking down under a power line and you're trying to locate, what we say, parallel or in line with the overhead line, you might get some false readings right there. Okay. That's in the 60 Hertz mode. It's going to be picking up the magnetic field from here, and it's going to be picking up the magnetic field from here. All right. You're unable to get a good locate on that. You potholed it. Well, it says here, but it's not. Or you're down here and you're finding something that shouldn't be there, look up in 60 Hertz mode. Okay, that's when you're going to have to put direct connect on somewhere. Another good practice here, and I know Professor B has done it, the induction method. We have found, here's my pad mount transformer and here's my secondary enclosure. If I put the box, and here's my suspected cable path, if I put the box directly on top of the piece of equipment, here's my handle and here's my handle, man, that induces a great signal. Right on top of the piece of equipment that you're in the spans that you're trying to locate the conductor on, like a pad mount transformer or a secondary enclosure. Works real good. Okay,
what's the distance you can go on that?
With high power, depending on soil conditions, I say maybe 200 feet.
Oh, wow.
Before you're going to get to your next piece. In direct connect, you're going to definitely boost that up 300 or 400 feet until you get loss of signal. Direct connect's going to help you out a ton there. And do remember, I've got my box sitting here. Here's a telephone pedestal. Here's a TV cable pedestal. That's all around the area too. You're going to be inducing a signal onto everything. Okay. I think it's time. I think you're muted, Professor B. I think it's time to, oh, he's on the phone. Let's go ahead and let me take a look at the time here. It's 10:34. Let's say about 10:50. We will be back. 10:50. Let's take a break, gentlemen.
Roger that.
Roger that. Professor B, do you see your share screen there? Okay, good deal.
Yes, I do. Yes.
Thank you very much. All right, so thus far we have talked about what voltages have we talked about this morning as far as locating and fault finding? What voltages? Primary or secondary?
Secondary.
Secondary. All right. the Dyna-Tel can be used, and you saw that guy using the Dyna-Coupler that one time, or you can't do direct connect, but you can do an induced sender. You can locate primary with the Vaughn locator through those two methods, but you cannot locate faults with it. The secondary fault locating system in the Dyna-Tel is just not strong enough to do anything like that. And two, it can't primary is going to be a little bit longer in length in most situations, and the frequency is not going to hold. You got a lot of insulation around a primary cable. So the piece of equipment we're going to use here, and they're very popular at our company, very expensive also, was a portable, what they call the Vaughn arc reflection system. So Vaughn is the company that makes it, and we're going to watch a video on this, and like Professor B did, we're going to stop and start it at certain locations.
The Vaughn arc reflection system is an easy-to-use, easily transportable cable fault location device. It allows.
So that's it. That's all you got right there. And now, back in the old days, the Vaughn arc reflection system, or the Vaughn system, had to be carried in a van. They were humongous. Now they've got it packaged into this one package deal right here, and it's powered by, I think there's 2 marine batteries that are in it, right? Plus electronics and capacitors to run up to drive up the voltage, but it's very portable.
Allows trained users to quickly isolate faulted primary underground cable. This video will highlight some basic operation features of the Vaughn. If you have operation questions once you're on a job site, please contact your Vaughn representative. In the West region, contact James Landers at 352-408-9630. In the East region, Canada and international inquiries, contact Jerry Landers at 352-408-7890. If you can't reach your representative, a number for the Vaughn Corporation and brief operational instructions are listed on the inside lid of your system. One very important note: the Vaughn Corporation recommends that operators use all of the safety measures demonstrated in this video. However, nothing supersedes the safety regulations of your company. If there is a conflict, always follow the safety rules and regulations of your company. The Vaughn arc reflection system combines a user-friendly cable radar with a capacitive discharge unit in a compact, lightweight, portable package that's easily transported in virtually every truck.
Lennon de la Latos is returned. All right, so Lennon de la Latos is back. Go ahead and resume.
Van or SUV. Let's see how easy it is to use the Vaughn system to locate a fault on an isolated cable section. But before we begin, here's 2 safety notes. If possible, all hookups should be performed using a hot stick and or properly rated rubber gloves, depending on your utility's requirements. We'll illustrate the hookup on a typical dead front pad mount transformer. Before you begin, remember the far end of the cable being tested must be parked and or open, not grounded.
All right, specifically, what do they mean here? I'm going to be testing a span, well, actually fault finding a span of primary cable. What do they mean by parked and not grounded?
They mean just like have it stationed somewhere, but don't connect it to ground.
Correct. That's one part of it. You got to have either, and some companies will do in this fashion, and it does meet the safety measures. If you have a person at the far end of the conductor and he's pulled that conductor off whatever it was feeding and sitting out in open air, as long as he stays there, you're okay. Parked means they put it on a parking stand where it can't go any further. All right, will that lightning arrestor, remember the open point that we saw out on our field? That one elbow that was parked down there, that lightning arrestor, will that work? What's it connected to? A lightning arrestor, correct? Can anybody hear me?
Yes.
Okay.
Guess I don't really understand the question, I guess.
All right, so when we looked at that enclosure and you saw, remember it was a normal open point,
Okay.
right? And the wires that came in on the bottom, they went into a lightning arrestor. That is parking. The cable's not feeding any other direction, it's parked, but it still had a lightning arrestor attached to it. Will that suffice?
Suffice for what?
Parking.
Oh, yeah, that would.
Yeah, because it can't go anywhere.
Be careful,
I mean,
gentlemen, be careful. Where can it go to? It's a lightning arrestor.
Well, I
To
mean,
ground.
it's a lighting arrestor.
There you go, there you go. All right, some people make that mistake. They'll park it on a lightning arrestor standoff and they'll start testing. Well, all that thing's gonna do is arc over the arrestor. Every time you try to test it, it's gonna arc over the arrestor. It's gonna give you a false reading. It has to come to a point when what they call a parking stand with nothing else attached to it. Okay, comes to a point and stop. Not grounded. Now, I'm going to show you a feature here that not many people use later on about the grounding part of it.
Begin by cleaning enough of the neutral bundle so 2 connections can be made. The green safety case ground Vaughn provides and the approved grounding jumper device that your company uses. Cleaning the connections is the most important step of the hookup process. Notice the lineman cleans the grounds and the concentric neutral of the cable under test. Vaughn recommends using a feed-through device so the parking bushing is removed.
Now, you notice the one that he took out right there. Hold on one second. Perfect example.
Vaughn,
It is parking. This is a parking stand right here that he has in the video, but there's nothing else attached to it. It just comes to this point and stops. That's a perfect example of a parking stand.
Okay.
That's where they had it located before they tested it.
recommends using a feed-through device so the parking bushing is removed and the feed.
Now he's got a feed-through device. I'm going to put one elbow on one side and then have an open port here. I don't know which one he's going to put it on. Then I'll have an open port here to put my test probe in. So right behind in this area right through here, there's actually just a metal bar in here. It's insulated, but there's a metal bar inside that feeds through from one side to the other. That's why they call it a feed-through insert.
Through installed. Make sure the cable that's not being tested has a bushing cap or cover to avoid inserting the high voltage lead into the wrong bushing. You can see here how close the feed-through is to the transformer bushing. That's why it's critical that any open bushing be covered with an approved bushing cover as illustrated here. Using a hot stick, the elbow is inserted into the feed-through and a grounding elbow is installed into the open bushing.
Watch this video here real quick because we're going to come back to this. So he put the elbow on, then he grounded the conductor. That's a good practice. But there's something going wrong in order here.
Some utilities test from the parking bushing by removing the access port cap. Then, using an approved voltage meter or detection device, test the other side of the feed-through or test port to ensure the cable is de-energized.
Okay, so what do we do first before we ground it?
Test it.
You test before you ground, guys. Okay, I don't know why they got this in reverse on the video. All right, you test it to see if there's any voltage present, then you ground it. Okay, if you hadn't tested first and you've got voltage on the cable, once you ground it, you're going to get a real big explosion right here. Test, then ground.
After you complete the testing, be sure to insert a grounding elbow in the feed-through. You're now ready to hook up the leads from the Vaughn. One quick note, be sure the green safety case ground is uncoiled fully before beginning the hookup.
All right, did everybody hear that? One big safety note.
Hook up the leads from the Vaughn. One quick note, be sure the green safety case ground is uncoiled fully before beginning the hookup.
one big safety note. What do you have to do with the grounding cable from the piece of equipment before you hook it up?
Make sure it's
Make it unsure uncoiled fully.
Uncoiled, right. I mean, this guy is right beside the piece of equipment. You got about 20 feet of that cable coiled up on the machine. This is the grounding cable. You got to uncoil it and lay it out. Lay it out in a straight line the best as possible before you hook it up. Now, here comes the supreme question. Why?
If it's coiled, wouldn't it
So something like
wouldn't it
maybe.
introduce voltage on that line?
It's not going to introduce voltage on it, but if voltage is introduced on the line for any reason whatsoever,
Yeah, it's gonna have a.
we're going to be introducing some here in a moment to test it. What's that coil going to do?
It's just
Explode.
gonna.
Go ahead, Ryan.
Explode?
No. When I take a coil and I introduce electricity on it, does it magnify current?
Yeah.
All right.
It's gonna get hot.
Yeah, we don't want to do that. Especially if you have a fault condition, we don't want to make it more intense. So uncoiling the wire takes out any kind of possibility of intensifying current or a magnetic field.
So it's kind of like making like a small step-up transformer.
On its own, correct. You will notice, and this is going to be going out there in the world, trucks are going to have to be grounded. Every time you set up a truck, you're going to have to ground that truck. Well, it's coiled up on the truck. What do you have to do?
Uncoil it.
Uncoil it. Okay, everything has to be uncoiled as far as grounding is concerned.
Begin by attaching the green safety case ground. Then, connect the high voltage return to the concentric neutral on the cable being tested as close as possible to the cable termination point.
So there's a green safety case ground uncoiled, right? There's no coil in this one. It goes right with the probe right here. I need a return path, just like in all electricity, right, to be able to take measurements and find out where the fault's at. So that's this one.
Next, remove the grounded elbow. And finally, insert the brass elbow probe attached to the high voltage lead into the bushing.
Okay, special safety note here, guys, when you're operating this machine or piece of equipment. Be in good communications. If you're the operator of the equipment and you have another guy here that's over here doing all your hot stick work, once he takes this stick off and he starts to test, this is all exposed brass metal. The machine will go up to 35,000 volts. Okay, be safe. Don't be standing around this. Don't accidentally trip and fall. That is exposed. So have good communications with your operator over here when he lets you know that he's starting to energize and test the cable.
You're now ready to find the fault. The operation of the Von Arc reflective system, regardless of your model type, is essentially the same. Brief step-by-step hookup and operating instructions are located on the inside lid of the Von reflective system for easy reference.
Okay, guys, be smart. What does red mean?
Danger.
Danger, Will Robinson. Pay close attention. Don't do this. What does green mean?
Proper procedure.
Good to go. Okay. You follow the instructions that are on the top of this lid right here, you can't go wrong.
Including the phone number for the Von Corporation. To begin, set the voltage indicator with the white mark up, then switch to the lowest voltage. Check the battery to make sure it's fully charged, place the machine in radar mode, and turn the unit on.
Okay, so there's two different modes to the Von arc reflection system. There's a radar mode, which is true radar. We're going to send a signal down the conductor. We want it to get to the fault location, and then it's going to bounce back and give us a reading on that display that you see up there. All right, very, very low voltage, but it does introduce a signal onto it. Then there's the thump mode. Thump mode is I'm not using radar anymore. I'm going to introduce a very high voltage onto it. Radar mode, signal, thump mode, DC voltage, high.
VON will then automatically find and mark the open.
Okay, so once you connect it and you've got it in radar mode and turn on radar mode, what's the VON do for you? It's automatic. You want to hear it again?
Yes, sir.
Sure.
Check the battery to make sure it's fully charged, place the machine in radar mode, and turn the unit on. The VON will then automatically find and mark the open.
Okay, what does it do?
Finds the fault.
Well, no, it finds, you got to watch that wording right there. It finds the open. Okay, we assume right now it's the fault. We're hoping it's the fault. But yeah, I like the way he terms right here. He finds the open point in the conductor. Now, here's an easy way to find that out. I'm going to take a wheel from this transformer right there and measure 250 feet to my next transformer. Well, if it says that's the open point by the display that I have up there, do I have a fault in the cable? I wheeled from one transformer to the next transformer. That's where I've got it intentionally open. Is there a fault in the cable? And the display reads 250 feet. No, there's no fault in the conductor, okay? This thing reads 250 feet of cable, but I'm showing an open point at 125. Uh-oh, guess what's halfway down the cable? A fault, okay? It'll give you a general radar reading of how far it is to the fault. Once again, I have not introduced voltage onto it yet. That's such a general location. Pretty nifty tool.
Next, push the green start button. The unit will charge to the level you've set on the indicator. It will then discharge and the fault will automatically be marked.
I don't know if you guys, and I usually typically draw this out. I will draw this out later on a white screen.
The distance to the fault from your test point is located in the lower left position of the screen.
So it'll automatically adjust to the distance away you are from the fault, okay? This is still in radar mode.
In this case, the fault is 394 feet from the test point. Now a second worker can travel the cable path the approximate distance indicated by the VON trace. The unit operator then presses the stop button and switches from radar to thump.
Okay, now he's getting ready to thump. And when I say thump, those marine batteries that are in there are going to charge up a capacitor to a very, very high voltage. And they're going to close a switch and it's going to send a ton of voltage down that cable. Okay, what's going to happen in the ground?
It's going to vibrate.
It's going to explode. The arc is going to explode in the ground. That's why they call it thump. Okay. If you didn't hear it the first time, the batteries are going to charge up the capacitor. They're going to send another high voltage down the cable. It's going to explode again. Okay, so here we go. He's getting ready to thump.
And presses the start button. The unit will then begin an auto thump sequence every 11 to 14 seconds.
You can barely hear it on the video right here. It just went thump. All right. Good indicators going on right here. When you're walking down, remember, you got a radar general location of where it was at from the radar mode. You can feel it in your feet when it thumps. All right. We actually use radios, and the guy would be at the other end if you're too far away. He said thump. As soon as it thumped, he said thump. And if you didn't hear anything, you got to be a little bit more precise and listen up real good, especially when there's traffic around. One great tool out there to use rides on your truck all the time. Guess what it is? Traffic cone. Take a traffic cone, put it down to the ground, put your ear to it. It will definitely intensify the thump in the dirt. Now you got to consider this thing's 3, 4, depending on what's going on here, maybe 6 feet deep. So that explosion is pretty intense down there. You don't want to thump the cable for hours at a time. You're destroying the cable.
Many features of the VON arc reflection system can be adjusted to fit your utility's needs.
Okay, you guys won't get into adjustments. Typically that's done by an engineer or somebody that's very knowledgeable in the piece of equipment. I can guarantee you, one URD primary is prevalent, and that's the one that's most used. So the machine is set for the conductor that you have out there. So let me unshare the screen. Oh no, I want to hold it just one second. The only way that you can really destroy this machine, it's in the lid, and it is specified right here on the side of this, is what kind of voltage you're going to introduce into the cable. Now, the voltage cable that we have outside and the voltage that we're using on it is 7,200 volts. You know, we don't have that on the cable, but it's meant for that. That cable is capable of 15 kV. It's 15 kV cable, but we typically run 7,200 volts on it. My Vaughn will go up to 35 kV. Do I want to push it that hard on 15 kV cable? No. Okay. I want to keep it, you know, if I want to do testing, I want to go between 7,200 volts and 10,000. All right, I'm 5,000 volts below what the range is of the cable, and I'm still above my other voltage, so I know I'm going to get a good explosion down there. You cannot adjust, and it's in this red sign right here, you cannot adjust the voltage while it is running. Do not press start and then adjust the voltage knob down here. It'll destroy the capacitors that are in the machine. If you press start and it goes down to 5,000 volts, press stop. Move the knob a little bit. Press start, goes up to 7,000, still not high enough, press stop. Move the knob a little bit more, press start, then you're at your voltage. Spelled out specifically right here. Who can take a guess at the cost of the machine?
20 grand.
$10,000.
All right, we bought the first two. They were $38,000 a piece. Okay, you don't want to tear one of these things up. All right, but don't be afraid to use it. Okay, read those instructions. If you want somebody by your side, get by your side. But learning both the Dyna-Tel and this piece of equipment will make you cream of the crop. Okay, so let me unshare this. Let me go to a white screen. I'm going to show you a couple doomaflachis here that'll help your day. So,
Mr. Shoemaker, when are we going to use those?
we don't have one. We can't afford one. Right yet. All right. Plus, we're working with a voltage that I think is a little bit out of your guys' range right now. All right. So, I'm going to draw a sample of the display that you saw up there for the display, and that is a great helper. All right, so you got this display on the screen right here. Once you attach to the conductor, you're going to get a bunch of squiggly lines. That shows the beginning. It's going to go out, and you're going to have a small hump, and then it's going to continue out. The machine automatically is going to put a hash mark here, a hash mark here, and it's going to say in the lower corner 345 feet, whatever the distance is. All right, that's the full span of length of cable. That's going to be automatic. If there's a fault in the cable, it's going to have a bunch of these squiggly lines at the front. It's going to go out. You're going to have maybe a small diversion right here, and then the end of the cable right here. Then he's going to press the knob. This is the second part where you press the knob. Another trace is going to come into the display. It's going to go down like this, and guess what happens to that little hump right there? This is the one you want to use. It's automatically going to give a hash mark right here. That's the beginning of your cable, and it's going to give you a hash mark right here, right at the beginning of the fault, and automatically at the bottom say 168 feet. That's between the two. You have now radared to the fault location. This is where the guy took the wheel, he went down. and he got a general location. Then the guy put it in thump mode. He heard the sound, put a mark on the dirt. These things are really reliable and great. Okay. One special note here. Remember the front of the video out there where he said the cable is parked and not grounded? Remember that?
Yes, sir.
Okay. There are some cases out there where you're not going to be 100% sure that this is the end of the cable, and you need to verify it. Some faults are so minute in the ground that they're undetectable. Okay. Some faults are so intense that it burns the conductor completely in two. If it burns it in two, it thinks it's the end. So you need to verify that. Here's a very simple way of doing it. Put it in radar mode. I'm gonna make this bigger so we see it better. If this is considered an open, remember before we had a fault location like this. When we put it in radar mode and thumped it, what did it do? Went way down like that, correct?
Yeah.
To verify the far end, to make sure the far end, what can I do down here to make this invert and verify that I'm on the far end?
Move the machine and take a new measurement.
No, you leave it right where you're at. Remember, this is a phase to ground fault in radar mode. But I want to verify my end. What can I do to it to make this thing go from up to down in radar mode, not thump mode?
Ground it.
Ground it. Perfect. I'm going to call my guy on the radio. I'm not 100% sure we're at the cable end down here. Can you go ahead and ground it? He says, I've got the ground on. This thing is going to do like that. Take the ground off. It's going to go back up. Put it back on. It's going to go back down. You have now verified the cable far end. Okay. Any questions there? I mean, the Vaughn, you look at the front of it, lots of knobs, lights, and all kinds of cool stuff going on in that thing. You follow the instructions in the lid, and it begins like to be like clockwork. All right. Safety is key here. Before I thump cable, what do I tell my fellow employees? Anywhere, working on the job site.
Just let them know.
Let them know what you're doing.
Exactly. Hey guys, stand in the clear, getting ready to thump. Anybody that's around the transformer is going to stand back. If I've got anybody on the far end waiting, they're going to back away, stand back. Is the guy walking on the ground okay? Yeah, he's all right because it's arcing into the earth and the ground, not his feet. There's no step potential going on down there. It's on the surface where step potential happens. Always inform your fellow employees getting ready to thump. All right, 35,000 volts DC. Hertz. Okay, any questions there? All right, let me see. Professor V was on the phone, so let me clear that one and see where he wants to go next. Hi, Professor V.
Yo.
I'm done with the Vaughn arc reflection system.
All right, so you got all that done?
Yes.
Okay.
Quick question: Do those two companies, Dynatel and Vaughn, do they have like a correspondence, training course?
Well, here's how they usually work, and this works with your trucks as well. Usually, if you get something new from them, they'll bring in a representative and they'll have a class on.
Okay.
In your company. If one already exists in your company, you're going to learn from fellow coworkers.
I was thinking like more specific before you get into a company and make yourself look more competitive.
You're getting it.
Okay.
Right. And we don't expect you to know 100% of it. All right. And I wouldn't think you would remember 100% of it. But I'll give you this example right here. Last year, I had a graduate come out of the program that went to work over at HTC, and this is in the first week now. Went over to work for HTC. They went out and did a couple jobs, and they had to go to another location and find a fault in a telephone cable going to a house because they had to replace it, but it was lunchtime. Guess what my graduate did?
Called the number. Called you.
Nope. He took out the Dyna-Tel. He removed the telephone cable from the pedestal and removed the telephone cable from the house, hooked it up, found the fault, dug it up. He didn't have the stuff to splice it with. When those guys came back from lunch, I'll tell you one thing, Craig Johnson called me that afternoon. I didn't know that you taught how to use a Dyna-Tel. I said, yes, sir. Yes, sir, we do. Well, your boy right here had it done. All we had to do was splice it and we were finished. There's your icing on the cake. Okay. And really what he did, he told me what he did is he opened the box up. Well, I don't remember where this goes. www.google.com. I know Shoemaker said something about 90 degrees. I knew he said something about the probe. You know, he just pieced it together.
Gotcha.
You guys can do that too. All right, Professor V.
The only thing we got left for the quiz is the high pot adapter.
Okay, your ball of wax, bud.
You want to take a break?
Yeah.
It's 11:22.
Yeah, let's do a quickie right here. And we'll push it out just a little bit today and get that phasing sticks in, and then we'll be good to go. Yeah, Ryan gets to smoke in his house. We can't smoke in this building. All right. So we'll be back 11:35.